so this talk was prompted by, we often asked, and I say we, researchers and others, often get asked, what's the difference between a vocabulary and an ontology? And so there's sort of a bit of a pun going on there in the title here, but vocabularies and ontologies, similarities and differences, definitions and structures. So there's a continuum here. I'm going to talk about that. The mini agenda is just that Simon will introduce a bit of theory about vocabularies and ontologies and their similarities and differences. And then we're just going to step through 5 implementations of vocabularies. You've seen a very impressive one just then. And we're going to go through 5 that are on that spectrum, and then we'll just conclude in a minute or so. So Simon, over to you.
Yeah, and Nick and I were preparing this morning, so it's not necessarily going to be that slick. Anyway, yeah, it's great that we've just had the presentation that we just saw. We're probably going to be looking a little bit more behind the scenes here. Yeah, so I'm seeing slide 2, great. Just to motivate it, first we'll take a look at a simple vocabulary. There's 2 approximately similar versions of almost the same thing here. If you'd select that first link, thanks, Nick. Are we going there?
Can people see the web page that I'm now showing? Probably not.
No.
Oh dear. This is
not going to be.
Is it? I think I'm showing. I'm going to cut back to the browser, and we're just not going to have to see things in presentation, but that will work. Okay.
Yeah, I don't have any transitions, so it's okay.
Yeah, so you should now see the web page.
Yeah, so if you just scroll up to the top, just so we see the headers there, this is a list of so-called agent roles. This list, I think, comes from the Dublin Core list. So if you scroll down now, you see that there's a whole set of the kinds of functions that a person or a job position might have in respect to some information resource. So all those terms on the left would make sense if you just scroll up just so we can see the headings here. What we're looking at here is a very flat SCOS vocabulary, where each of the items you could click through, but you won't find much on those, has just basically got a label and a definition or description with no hierarchy here at all. Thanks, Les. Looks like the Dublin Core set. The other link that we had back in the presentation there is a related set which comes from the Geographic Metadata Standard. You'll see almost all the same words. There may be a few more in there. Funder and mediator and these things as well. But again, this is just a flat list. Principal investigator, there's a cool one, right? So this comes from a more scientific domain. So this is formatted just in SCOS, as we heard from the previous, if you go back again, Nick, to the presentation, as we heard from the previous, that's the one I wanted to see, the previous presentation. SCOS gives you a basic hierarchical vocabulary structure. In the left here, this is literally the definition of SCOS concept as it comes in the SCOS standard in the RDF representation of that. On the right, you see a sort of a pseudo UML picture of the class SCOS concept and all the properties that might be from that. And note for those people who are already familiar with thesaurus and vocabulary standards, SCOS is not a full implementation, but is certainly inspired by, or the intention is to provide an RDF compatible implementation of the well-known ISO thesaurus and vocabulary standards. I've noted there that 2788 and 5964, which everyone kind of knows and loves, or at least is vaguely aware of, has relatively recently been replaced by 25964. So a SCOS that's the definition of SCOS concept. Actually, just flip through to number 6 first, actually, Nick. So here's an example from a vocabulary which I've been managing, working on for a number of years now, got papers written about, was published through the SysVoc service, which we developed at CSIRO in Perth. And there you see in all its glory the definition of something called the Cambrian, which is, those of you from the natural environmental sciences would be aware that that's something important in geology. It's a time period which started 542 million years ago and ended 488 million years ago. You know, well before any of us were aware, but it's very much a central part of historical geology. You can describe the Cambrian using SCOS, and that's an attempt at doing it there. And you see there's quite a lot of relationships there: narrower, broader, transitive. That's the next step out. This particular one is taken from a resource which is the International Stratigraphic Chart from 2016. Also, we got lots and lots of labels for that in different languages, including some non-Latin languages, which you can see down at the bottom there. Okay, so flip back to number 5, please, Nick. We've worked on the gory details of what a geochronologic era is, which is the Cambrian is one of those, and you can design a much more semantically rich information model for that, which is shown pictorially on the right there, and on the left, that's the turtle encoding of the RDF implementation of that as an OWL class. And you see that in bolded in the middle there. I've said we're going to say that a geochronologic era is a SCOS concept. It's a subclass of that. All geochronologic eras are also SCOS concepts. But we've also got a whole bunch of additional geology-specific properties added in there. And if you flip down to number 7 now, Nick, so that same individual, Cambrian, which before I showed just as a SCOS concept, when you add in the additional properties which come from geology, like the rank of this thing, that it's got a beginning and end, which comes from temporal topology basically, and that it is an interval and contains other ones, and its end is coincident with the end of something smaller, and its beginning is coincident with the beginning of something smaller, and it nests inside all those things. That's all those bolded properties that are on the right hand side. So the beauty of this technology platform, the RDF platform, is that if you only want to think of it in terms of SCOS, you can do that, which is what I showed on that slide 6. But if you want all the additional semantics that you get when you really head into doing it as a full-on geochronologic era, which is also, as you see there, a proper interval from the time ontology, then those can be added in without getting in the way of viewing it just as a simple concept. And in the past, I've published these through vocabulary services with the idea that when viewed purely as vocabulary fodder, if you like, you can use any you can query it using all of the SCOS properties, but if you are a geologist and you know more about what this concept really means, then you can query it or view the information about it using the richer properties. And in the previous presentation, we saw flipping within the pool party environment. Well, actually, no, it was in your interface, wasn't it? Or maybe it was pool party, looking at it through the SCOS interface. But then, as you said, you had all the additional clinical properties associated with the drug, what it was designed, what conditions it was designed to treat, which are obviously go way beyond the semantics that you just have in the simple knowledge organization system or SCOS. So we're really, in the work that we're doing, is trying to preserve the anchor back to SCOS while also providing the using the possibilities that you get from vocabularies. Sorry, from OWL and ontologies, and of course those concepts I showed in slide 5, the definition of geochronologic era itself would need to be published in some kind of register of ontology definitions. And that could, a list of things like geochronologic era and stratigraphic section and geochronologic boundary themselves would form a richer kind of vocabulary, a vocabulary of those geologic time terms. So I'll pass over to you now, Nick, and you can flip through those examples.
All right, so just before I do that, I'll just mention that SCOS itself, for those who are unfamiliar, is actually an ontology. It just happens to be an ontology about vocabularies. So ignoring the slide I've got on the screen for the moment, things that are formalized in ontologies can be formalized in SCOS and other ontologies because SCOS itself is one of those sorts of ontologies. So I'm going to skip over a couple of slides because we're a little bit short on time, but I'll just talk to them very quickly. So one of the first examples, or the first example here is the Global Agricultural Concept Scheme Core, and that's just a very big flat SCOS vocabulary. So it's got a lot of terms in there. It's delivered with a tool that's similar to, but it's a different tool to the pool party tool that we saw before. It's definitely in the vocabulary land. So it's vocabulary, not ontology there. The next one, and so of course people can click on these links in their own time and you'll see the interface that's provided. It does have machine readable versions and it has HTML web pages and so on, but it's definitely in vocabulary land. Now, geologic timescale, Simon's actually talked about that, so we'll skip on over, but just a reminder that it's both a vocabulary plus, so it's got a couple of extra fancy bits. Another similar one is an observed property vocabulary that Simon's also worked on, and I will click on this one because it's going to, if I do it right, show us a slightly different tool. So this is the linked data register, which Simon actually did show before, and like both the pool party tool and others, it's got various tooling to help you get around vocabularies and so on. Now, in this case, this vocabulary is a vocabulary plus. It has some other properties, and I have to look at the slide to remind myself what they are. Yes, so we can look at...
Any of those soil moisture ones would get, yeah.
Yes, so here we go. Here's the information about deep soil moisture, and there are some other things like features of interest that are related to this term that are clearly not SCOS things. Okay, now this next example, example 4, is the one that I think best highlights vocabulary and ontology differences because it's actually both. We've got two things there. So the first thing I'm going to show you is a vocabulary that is used to classify physical samples. And that's the vocabulary bit. So you can see in the name here, it's got the word voc for vocabulary. And then separate to that, we have an ontology as well. And I'll talk about the similarities and differences. So looking at the vocabulary, this vocabulary has got terms like blast. The blast is a method for extracting samples. And it's got a whole bunch of other terms in here. DOIs are relevant to samples because maybe you want to use them for identifying samples. Dredge, that's a sample getting thing. And this is just a list, and it's derived from an XML code list. So in the normal way of doing business, you can define a code list, and then you can take that code list, set it up in linked data and SCOS, and now you've got a SCOS vocabulary. So that's the code list. Now the ontology, very different beast. The ontology is a data model around things of interest to samples, and I'm using an ontology viewing tool here to actually turn the ontology into HTML and text. And it tells you about the classes of things that you might want to know about in relation to this sample, or to samples generally. So it's like the ontologies that Simon's just mentioned, and there's some pictures somewhere or other in the documentation that will show us what, graphically, what the classes of interest, we think of interest around a sample are. But what's critical about these two is that the ontology actually uses the code list. And I'm going to show an example from a live system here, which is GA's sample catalog. So what this is doing is it's just a landing page for metadata about a sample. And I'm now going to click on the RDF or turtle view of this. Now, I'm wondering if this is going to actually be visible.
It just did a download, Nick.
Yeah, I know, and I don't know how to change that. Sorry, I've got a new.
Well, go to your downloads page and.
No, I can do it manually. If I
.ttl. There you go. Whoops. Text.
Yeah. I think this will force a download still. Hopefully, yeah, it's going to force a download still. Okay, I can't show you folks, but I can describe it. You can see here this this sampling feature. So that's a property, or that's a class that's related to the sample, and it has the term borehole. So that's an ontology property. There's nothing SCOS about that. That's a special thing that you have to know about samples and ontology and to describe. But the sample type, it's got the word core here, and core's a URI, and that URI actually links to a term within this code list. So here we have the ontology specifying some relationship, in this case, the relationship of sample type, and then it's using a term from the code list to actually instantiate that. So here we have an ontology using a vocabulary. They're both available for use to describe samples, and from a management point of view, the update cycles are very different. We expect the ontology to be updated very rarely, whereas the code list we would expect to be added to quite frequently. So the last one I'm not going to demonstrate, I'm just going to mention, example 5, this is the prov ontology. So it's a core W3C ontology for describing provenance, and it is not at all a vocabulary. It is a data model, and there are no individuals or instances of things that you can refer to directly in prov. So if you look at the prov documents online, you'll see you'll see classes that you can use. So there's a class called entity, and you can describe your data items as an entity and link it to people, which prov would describe as an agent. But there's no sense in which there's a list of individuals that you can refer to. So it's right at the other end of pure ontology, not vocabulary. Okay, we've definitely blown our time, but that's it. So I will stop sharing and hand back to Kim.